Solving quadratics by factoring. The first thing we always want to do is always check for a GCF, okay, a greatest common factor. So in doing that, the steps are to identify the GCF, and then factor it out. So looking at the first example, I see that I have a 4 and an x, and 4 is a factor of 12, and there's also an x. So the GCF is 4x. So factor that out. And then to solve a quadratic, you just set each factor equal to 0. So you get x equals 0 and x equals 3. So in the second example, we have x squared equals negative 2x. The first thing before you can even factor out anything is to put everything on one side by adding 2x. Now identify your GCF, which is x. Factor that out. And then set each factor equal to 0. So you get 0 and negative 2. Factor by GCF. A difference of squares. First thing you need is a difference of perfect squares. Okay, so I'm going to abbreviate here. And then the first thing you do is, after that, is find the square roots. Then you separate your square roots. And then one is a sum, and one is a difference. Because that's how you don't have the middle term. So here, the first one, there's no GCF. Take the square root of x squared, the square root of 9, and you get then x plus 3, x minus 3. Set each of them equal to 0. You get x equals negative 3, x equals positive 3. Again, you have to have everything on one side. Square root of 4 is 2. Square root of 81 is 9. So you have 2x plus 9, 2x minus 9. So you get x equals negative 9 halves, x equals positive 9 halves. In this one, we actually have a GCF of 2. Factor that out. Now we have a difference of 2 squares. Square root of 4 is 2. Square root of 1 is 1. So this ends up 2x plus 1, 2x minus 1, so that you get, I'm just going to shrink this so I can squeeze it in here, so that you get x equals 1/2, I should say negative 1/2, x equals 1/2. In this one, we don't have, it's not in standard form, which is fine. Let's just go ahead and factor out a GCF of 3. So we end up with 9 minus x squared. It's still a difference of 2 squares. It's just that it's in the opposite order. So we still get 3 plus x minus x. Set each equal to 0, and you'll still get x equals -3, x equals positive 3. Perfect squares. Trinomials where our leading coefficient is 1, or a equals 1. This, so none of these will have a GCF. So doing this as EC method, or just using the factors of the last term. So it's going to be what some people call a double bubble. So you're going to create the double bubble, which is the 2 sets of parentheses. Then you separate the x squared. Find the factors of the constant. And you want it such that they add to the middle. So if you remember our factoring rules from before, hopefully you can just follow through with that. So these are both going to be pluses. Factors of 1 are 1 and 1. And set each of those equal to 0. You just get x equals -1. In this example, we don't have everything on the same side, so we have to do that first. Factoring, like I said, we did that. We've already done that, which is why we've already done that, and we're just extending it by setting each factor equal to 0. Making sure that you have everything on the same side first. Here we have a GCF so that we can have that leading coefficient being 1. Factoring this, setting each factor equal to 0. And the last one, factor, set each factor to 0. And this is the first part of solving quadratic